All right, ladies and gentlemen, welcome to section 1.6. We're going to be dealing with a lot of different types of equations to solve. So go ahead and get yourself ready. We're going to be looking at polynomials or special polynomials here in this case, that are not quadratics. We're going to look at some radical equations or square roots, some absolute value equations, some rational equations, and a little bit of compound interest there at the end. All right. So let's start off with polynomial equations. The polynomials that we're going to be dealing with here are of a certain type in which we can use factoring to solve. And some of them you're going to have to factor and use quadratic formula because we're going to be dealing with something larger than x squared. So for this example here, we would write this in a little bit different form. We need to set things equal to 0. And when we set things equal to 0, we would say, okay, 3x to the fourth minus 48x squared equals 0. And when we solve this one, we would have to factor out the common factor. So in this case, they both have a 3 and they both have an x squared. So when I take that out of the 3x to the fourth, this would become x squared. And I took all the x's out, and a 3 out of 48 becomes 16. And after we factored out that GCF, we can say that 3x squared times, well, x squared minus 16 is x plus 4, and x minus 4 equals 0. And then we need to look at each separate piece to solve for 0. This piece is x equals 0. This piece, x equals negative 4. And this piece, x equals 4. So notice we get many, many answers. So we get 3 answers here in this particular case. All right. Sorry. For a thing called a sum or difference of cubes, this would be something like this, x cubed minus 8. You need to know that 8 is really 2 to the third power. And a difference of cubes in this case looks like this. If I have something cubed minus something cubed, I can factor it to a linear piece times a quadratic piece. So in this particular case, I would say this is x minus 2 for the linear piece. X minus 2 here is my a and my b, times the first thing squared plus the first thing times the second thing, so 2 times x, plus the second thing squared, so in this case 4, which is 2 squared. And that would be factored. So we would say, okay, x equals 2, and then for this piece, you would have to use the quadratic formula in order to solve to figure out any other answers to this statement. All right, now this says sum or difference. For a difference of cubes, it's this. For a sum of cubes, it looks like this. If I add 2 cubes together, I can also factor it to a slightly different factoring, even though it's basically the same thing. Okay, I will give more examples here in just a second. The last one here is a quadratic type problem. Now, this is what we call a quadratic type because it kind of looks like a quadratic. It kind of looks like x squared plus 5x plus 6. And we know that this factors to x plus 3 and x plus 2. Well, in this case, this is actually not x to the second. It's actually x to the fourth, which is actually something squared plus 5 times something plus 6, which means each of these are actually squares. And you can then solve this. If this says that x squared plus 3, here I can say x squared plus 3 equals 0, and I can x squared plus 2 equals 0. I would subtract 3 and then take the square root. So that tells me that x is equal to the square root of negative 3, which is actually I times the square root of 3 like we learned yesterday or the other day. And this is both plus and minus because I did this. I said x squared equals negative 3. So x is equal to plus and minus I root 3, or the plus and minus the square root of negative 3. And likewise, I would get, subtracting 2, taking the square root, I get plus and minus I radical 3. So let's look at a couple examples of these type of problems. I missed one little type. I'll put it in here too. If you are given a cubic like this, most of the problems like this that you're given today can be factored using grouping. So if we look at the first group, the GCF is x squared, so I would get x minus 4 when I factor out, oh, sorry about that. Let's try that again. X cubed minus 3x squared plus 3x minus 12 equals, sorry, minus 9. Oh, sorry. It was plus 12. Oh, goodness gracious. Let's try that again. I was writing the wrong problem. Let's try it one more time here. X squared minus 4x, x cubed minus 4x squared minus 3x plus 12 equals 0. I can factor the first part, so I get x squared times x minus 4. And if I look at the second piece, I can factor out a minus 3, so I get x minus 3 times minus 4 gets me that plus 12. And then I can factor, they both have an x minus 4, and I'm left with the x squared minus 3 equals 0. And notice it's now factored, so I can say x minus 4 equals 0, and x squared minus 3 equals 0. This one, if I add 3 and take the square root, and this one I just add 4 and I get 4, so I get my 3 answers that I needed. If I was to do something of a quadratic type, so if I had x to the 6th plus 3x squared, or sorry, cubed, plus 2, I can actually factor this. You just have to look and see that this number is double this number, and it should be a quadratic type. And I can actually factor this to x cubed plus 2 and x cubed plus 1 equals 0. You notice that x cubed and x cubed make x to the 6th. I get a 2x cubed and a 1x cubed. That makes 3x cubed. And then my last is plus 2. So then I can actually say this. X cubed plus 2 equals 0. This one's a lot more complicated than the others because this is now x cubed plus 1, which means I can actually do a lot of extra stuff here. I can actually say this is x plus 1 times x squared plus, minus 1x plus 1 equals 0, and you get x equals negative 1. But you also get the quadratic formula answers. And for the most part on this case, if you got a problem like this, I would just allow this version. Cube root of negative 2, and I'm okay with that right there. I don't think you're going to get any examples quite as advanced as this. But I just really want you guys to be able to factor good problems like this that aren't just quadratics. All right, so I've shown you the difference of cubes example. I've shown you ones where you can factor. Let's go ahead and move forward to the radical equations, or equations involving radicals, meaning square roots. So this is the how-to. So first thing is you need to get the radical or the piece with the exponent. And what I mean by exponent, your exponents are going to be fractions. Fractional exponents. So if you had x to the 2/3 or x to the 1/2, you guys have to understand that x to the 1/2 really is the square root of x. So this is why this works for both. Oops. You need to raise both sides of your equation to the reciprocal of the exponent. And you must check your answers to make sure all of them are right or to see if you got any extraneous solutions. Let's go ahead and try. If I was to do 4x to the 3/2 minus 8 equals 0, I need to add 8. I then need to divide by 4. And then I use, now this was the first part of the problem. It says take or get the variable with the exponent by itself or get the radical piece by itself, which is technically this. This is the radical here. And I'm going to take both sides of the equation to the reciprocal of the exponent. And if I do this, x to the 3/2 to the 2/3 is going to be x to the first power because we multiply exponents here. And here I get 2 to the 2/3. And if you did this on your calculator, you would get something around 1.59. And that would be your answer, about 1.59. Likewise, we could do something with a radical, an actual square root. If I was to give you something, let's say like 2x plus 7 minus x equals 2. In order to get the radical by itself, I need to add x to both sides, and I get the square root of 2x plus 7 equals x plus 2. Plus x and plus 2 makes x plus 2. Now I can square both sides. When I square the left side, the whole point of that was to get rid of the square root. When I square this side, I have to square it, so it means I have to FOIL it, which becomes x squared plus 4x plus 4. And in order to solve this, I must set it equal to 0, so therefore I'm going to subtract 2x and subtract 7. So I get 0 equals x squared minus 2x minus 3. And I'm pretty sure this is going to factor to x minus 3 to x and x plus 1. So therefore, x equals 3 and x equals -1. But here's the thing, I have to check my work. If I plugged in a 3, so this is my check work up here. If I plugged in x equals 3, I get the square root of 6 plus 7, right? 3 times 2 minus 3. Does that equal 2? Well, 6 plus 7 is 13. That's not a radical, which means that doesn't work. Oops. I just realized what I did wrong. Scratch, 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 scratch. I'm minusing 2. This is supposed to be a plus 2, so therefore it's a plus 3 and a minus 1, which makes that a -3 and a plus 1. Let's check that again. If I had a -3 and I plugged this in, if I took the square root of plugging in -3, that becomes a -6 plus 7 minus a -3. Does that equal 2? Well, -6 plus 7 is 1. Minus a -3 is plus 3. And that does not equal 2. So now I have to check the solution for 1. If I check the solution for 1, I would get 2 plus 7 minus 1. Well, 2 plus 7 is 9. Square root of 9 is 3. Minus 1 is 2. So therefore, x equals 1 works, and x equals negative 3 does not. I'm going to do one more type like this so you guys have an extra example. And this is going to be kind of an ugly one here. For some people think it's ugly, but it's going to be the square root of 2x minus 5 minus the square root of x minus 3 equals to 1. Now, you have to get one of the two radicals by itself. So what I'm going to do is I'm going to add the second one to the other side. So I get 2x minus 5 equals 1 plus the square root of x minus 3. Now I can square both sides, but this is what makes this problem challenging. When I square this and I square this, this becomes 2x minus 5. But this I must FOIL. So this becomes 1 plus square root of x minus 3 times 1 plus square root of x minus 3. 1 times 1 is 1. I get one of these x minus 3s and another one of these radicals, so I get a plus 2 radicals of x minus 3. And then it's going to be plus this thing squared, so it's root times root, which makes just the x minus 3. And now I have to get that radical, another radical by itself. So I have to persevere on this problem. I have to subtract x from both sides, so I get an x, 2x minus the x. I'm going to subtract 1 to get negative 6, but I'm going to add 3 to get a negative 3. Now I have the radical by itself, so I'm going to square it. On the left side, I now get x squared minus 6x plus 9 equals 2 squared is 4 times x minus 3. This is actually a 4x minus 12, so I'm going to subtract 4x. This is a minus 12, so I'm going to add 12. And then I'm going to assume that every single one of you can factor this and solve for the 2x values and make sure you substitute both to see if they work. But let's go ahead and move forward to absolute value equations. So let's look at the how-to before we look at the what they are as an example. The expression that's inside the absolute value can either be positive or negative, which means you need to create two equations and solve both. The very basic example would be the Algebra 1 example that says absolute value of x minus 2 is equal to 3. That means the thing on the inside of the absolute value could be 3, but it could be negative 3. And I solve both of these statements. So I add 2, I get x equals 5, and here I get x equals negative 1. And both of these answers work for this original statement. But we can make things a little bit harder, more of a Algebra 3 style here. If I said absolute value of x squared minus 3x is equal to negative 4x plus 6, that means the thing on the inside, x squared minus 3x, could equal negative 4x plus 6, or x squared minus 3x could equal the opposite of negative 4x plus 6. And I would have to solve each of these separately. Here I'm going to add 4x. And here I'm going to subtract 6. I get that statement there. This tells me that x is equal to 2 and negative 3. Here, this is actually a 4x minus 6. So let's take a look at that. I get x squared. I'd have to subtract 4x and add 6. This one also nicely factors for us. And this tells me x is equal to 1 and 6. And when you substitute these in, you must check your answer here. You would notice by plugging these values in that only the negative 3 and the positive 1 work. So this one, the 6 and the 2 don't work. And you would notice that by doing your substitutions and seeing which ones work. Okay, moving forward. Another type, your fraction equations. We've kind of gone over this a little bit before. We must multiply both sides of the equation by the common denominator and solve as before. So if I was to, if I was to use some sort of an example here, let me find a good one. Let's say we had 2 over x squared plus 1 plus 1 over x equals 2 over x. I need to multiply the whole equation by the common denominator. Well, in this case, my common denominator is this x piece that I have and the other piece that I have, x squared plus 1, because they don't have any common factors. So when I multiply all the way across, the x squared plus 1 cancels. I'm left with a 2 times x. Next one, I multiply here. The x cancels, so I'm left with a 1 times x squared plus 1. And the last one here, the x canceled. I'm left with a 2 times x squared plus 1. And now all it requires is a solve as before type statement. So this becomes a 2x plus x squared plus 1 equals 2x squared plus 2 using distributive property. Then I need to get everything on the same side of the equal sign. So I'm going to say this is 0 equals. So I'm going to subtract x squared. I get x squared. I'm going to subtract 2x. I get negative 2x. I subtract 1. I get plus 1. And lo and behold, this also factors to x minus 1. X minus 1 equals 0. So therefore, x is 1. And you'll notice that this is the actual solution. So pay attention to multiplying by common denominators. Okay, last piece here. Compound interest. This is very important for us to know because this is a very important equation. Sorry, excuse me. This is a very important equation. Okay, A. I'm going to list all of what these things are, what these mean. A is your balance in your account. I usually say amount, so you guys know the word A. Amount in account. It's your balance. It's what your bank account actually says. P is called the principal. or we're going to call it the original deposit, or the amount invested. R is the interest rate as a decimal. Oops. Your N is the number of times compounded per year. Number of compounds per year. So if it said compounded monthly, N would be 12. If it said compounded quarterly, N would be 4 because it's 4 times a year. And then T should be kind of obvious. T is time in years. So T is the amount of time in years that this is going on. So make sure you have all of this. If I said you deposited $25,000, let's say you deposit $25,000 at an interest rate of 20%, 0.2, compounded monthly for 3 years. I could figure out how much would be in my account by doing this simple math on my calculator. So that's all this talks about. $25,000 put into my account at 20% interest compounded monthly. I would figure out how much money I would have after a total of 3 years. Here's your assignment. Get started on this so you can come to me with questions tomorrow. Remember, the 2 classes, periods 1 and 5, have a quiz on Friday on sections 1.4 and 1.5 only. So solving quadratics and using imaginary numbers or complex numbers. And have a good evening, and I will see you guys tomorrow.